All right, welcome back, wonderful people. Well, let's see what we have going on today. So, by the end of this section, you will be able to solve systems of equations by elimination and solve word problems by using the systems of equations. All right, so it's a little bit of more of what we did the last time. So if you remember last time, we were using substitution. So for substitution, you had to isolate one of the variables and plug that into one of the other ones, so one of the other equations. But what this one will be, it's different, what you need to know. So first thing is we got to line up the equations. So this means that every part of the equation has to be the same for both of them. So if they're both in standard form, for instance, then they both have to be in standard form. The equal sign has to be in the same spot, and x and y's have to also be in the same spot. So that's what it means by line up the equations. Multiply, so sometimes you might have to change one of the equations. So one or both of the equations to result in a variable that has the same coefficient. Now you're gonna have to add or subtract the equations to eliminate that variable. So one of them you might have to change all of the signs so that one of the variables is gonna be eliminated. And then solve for the remaining variable. So it's the same thing we did the other day when we were talking about two people, say for instance, climbing a hill, right? So if there's like a hill, you have two people, right? You might have one person climb the hill first, and then the other guy is going to help the other one up. So the and then eventually they're both going to get on top of the wherever they need to go. And then, so you take that, once you have the one guy up, then he's gonna have to help the other guy up. So substitute your answer from step 4 into the original equation to find the other variable. All right, so let's go ahead and start working on some of the examples. And like I said, sometimes it's just, once you get started and working on some of these, it makes a lot more sense and you're just like, oh, okay, well now that seems a little bit easier than when someone's describing it. So first thing we gotta do is line up the equation. So here I have x's first in both equations, that's good. Then we have y's, which is again, good. The equal sign is in the same place, and then we have our regular number, our constant values, on this side by themselves. So these are ready to go. Now we have to get one of them to eliminate. So let's see if anything is ready to eliminate. Y is not going to eliminate, and X has the same coefficient. Okay, they have 1 and 1, so they both have a coefficient of 1. So this is good. We want them to be the same number, but we also have to make it so that one of them can be subtracted from the other so that it's gone. Remember what we were talking about the last time when we were talking about substitution is that we have to get rid of one of the variables because you can't solve something when you have two variables. So we have to get rid of one so that we only have one variable left. So, and then it says for step 3 to add or subtract one of the equations. So that means we're gonna have to change one of these. Now for this one here, I'm gonna go ahead and just change it to basically what I'm doing is I'm multiplying everything by -1. Okay, so multiply everything by -1. And what that does is it changes the signs on everything. Okay, and I could write this over again, which would be probably a better idea. But anyway, this works out. So x minus x would be 0x. Which would be nothing, so we don't really need that. And that's going to be the one that eliminates. That's why it's called solve by elimination, because we have to get rid of one of these. All right, now we have to add these two together. So 8y and 7 plus 17, so this would be 24. And there we go. Now we have one less variable. We don't have the x anymore. So now we can solve it for y. Divide both sides by 8 because I want to get this y by itself. y equals, and then 24 divided by 8 is going to be 3. So we have our first solution. And remember, we need 2 of them. So we're going to have this guy help us get the other one. So let's go ahead and take one of our original equations. Let's see. I'm thinking of this bottom one. Now, I'm going to use the original equation. So to get this one here, I'm going to, let's see, y equals 3. So I'm going to use the original one, x minus y, but we know y is 3 now. So where y is, I'm going to put a 3 there, equals -7. And again, remember, I changed this here. I changed this. So if I need the original, I can go back, and that's why it's probably a good idea to write out the whole thing again. All right, now I got to get rid of this 3, the -3. So that means I'm going to have to add 3 to both sides. And that should give us the x value. So x is equal to -7 plus 3. So that would be -4. And that's my second part of the solution. And now I have both solutions. So I'm going to go ahead and put them into an ordered pair. And remember, x goes first, so it doesn't matter which one you found first. You got to put the x first into the ordered pair, because remember, it goes x and then y. And a quick refresher too, if I were to graph these 2 lines, all right, if I graph them, then it would come out to be 2 lines on a graph, and they would intersect at -4, 3. So, and again, this is where it's true, where x and y values are true for both of these. So if I plug in -4 for x and 3 for y, that's going to come out to be, they're both going to come out to be equal. Right? It's going to be true for both of them. If I pick any other number, then it might be true for one of them, but not both of them. So this is the solution that both of them will be happy with. Okay, now let's go ahead and do the next one. Let me see what we got. So I have, check to see if they're in the same order, right? You got to make sure they line up, as they call it. So x, y equals number, x, y equals number. So they're both in standard form. It's okay, they don't have to be in standard form or slope-intercept form. They can be in whatever form. The only thing is they have to be lined up. And again, that means the equal sign also has to be in the same spot. So let's go ahead and combine these. And it looks like here I have 2 on both of my y's, which is good because we want them to match up. And not only do they match up, but they're already opposite sign. One is positive, the other is negative. So they have to be, because if they're both positive, like here, for number 1, if I added these 2 just like this, it would be 2x. But we don't need 2x, we need 0x. So I'm going to go ahead and put these together, just as is. 3x plus 5x is 8x. And this is going to eliminate, okay, that's going to be gone. But that's what we want. It's already basically set up for us. Because 2 minus 2 is going to be 0, so we don't need to have it in the next step. All right, now 2 plus 4 is 6. And then 2 plus 2 is 4, so that's going to be 8x equals 64. And this one's actually kind of an easy one, but I'm going to just stick with the steps, because if I ask you what number can I times by 8 to get 64, that would be a pretty easy one. So now I know that the first number in my solution is x equals 8. So now take that and I'm going to plug it into one of these equations. Which one would be a better one to use? And again, you don't need to follow the exact same steps that I do every single time. You can, at this point, have a choice of plugging it into the top or the bottom. And in this case, I'm going to just plug it into the top. I don't know if any of those would be a better option or anything like that. So let's go ahead and plug it in. So 3. So 3. And then x, so I'm going to plug in 8 for x, plus 2y equals 22. There you go. Just plug it into either one of those will work. 3 times 8 will be 24, plus And then from here, I'm going to get minus 24. And then 2y equals negative 2. And then I'm going to have to divide both sides by 2. And then we get y equals negative 1. Now this should be enough to get our solution. So again, put them in order. So x goes first and then the y value. Parentheses because this is an ordered pair. And there we go. Now we know the solution that will make both of these true is 8, negative 1. All right. All right, let's get on to the next one. Keep things moving along. All right, so let's see. Same thing. First thing we got to do is check to see if the equations line up. X, y equals number. All right, so they're both in the same format. They're both in the same arrangement, order, whatever you want to call it. But in this case here, we don't have any like coefficients. And not only that, but it's going to be really hard to pick one. So if I look at y, we couldn't, like if I looked at this bottom y and I doubled it, so it'd be 10y, it would still not match up. So I could probably think of a number that 9 and 5 could meet up at. And the soonest number they could meet up at would be 45. And that would mean I'd have to change both of them. Now, you can make things easy for yourself by changing the fewest things possible. So to change the fewest things possible, let's look at x. All right, and I kind of knew that it was going to be this way. To change x, all I'd have to do is just multiply this by 4, and they would have the same coefficient. Now, I'm going to have to change at least one of them. So I don't know if this is how it's gonna work, but I'm gonna have to change one of them. So I'm gonna leave this top one the same, but I'm gonna change this one here, and I'm gonna multiply it by negative 4. And I'm gonna write the number that I've multiplied it by, because if I make a mistake, I'm gonna have to go back and look at anything that might have gone wrong. Look at the steps. And this whole thing is pretty easy to make a mistake on, so you gotta cover yourself. So x times negative 4 is negative 4x. 5 times negative 4 is negative 20y. And then 4 times negative 4 is negative 16. Okay, and double check it, make sure I multiplied everything by 4, make sure all the signs are different, so it looks okay for now. Now I'm going to go through and let's see, negative 29y, and then I'm also going to need to combine these two, so 2 plus 6 would be 8. 4 and 1 would be 5, and they're both negative, so I'd make a negative number. And that would be negative 58. Now, if I ask you what number can I times by 29 to get 58, that would be pretty easy. So in this case here, I might have my first solution, which is y equals 2. So there you go, I got the first solution. The next thing I'm going to have to do is find the other one. So I'm going to have to pick one of the original equations to use. And again, it doesn't really matter which one you use. So I know some students, they get into this habit of thinking, oh, I don't want to take the wrong step and get lost. Well, you can't really get lost. And I think with elimination, you're unlikely to do anything that would make a big enough mistake. So with the other one, with substitution, I said the only thing you can't really do is plug an equation into itself. But in this case, I don't think that would be a problem. I think no matter what you get, you're always going to be able to plug it in somewhere. Anyway, so I'm going to plug it into this bottom one here. And I know that y is equal to 2 now, so 5y, but I know that 5 is 2, equals 4. And then, let's see, 5 times 2, so 5 times 2 is 10, equals 4. And then minus 10 from both sides, so I'm going to have to subtract here, subtract there. And x equals, let's see, 4 minus 10 would be negative 6. And that should be it. I should have both parts now. So my first part of the ordered pair is negative 6, and y is 2. So plug them in, and don't forget to put them in order, because that's one of the common things I see that goes wrong. Is someone might say something like 2 negative 6, because 2 was the first part they got, the first part of the solution, and then negative 6 was the other part. So they just out of habit, they put them in that order that they found it. So again, make sure you put them in the correct order of x first, then y. All right, so let's go ahead and move to this one here. Let's see, look for something that would be easy to get them to be the same number. Now, this one probably wouldn't work because I cannot multiply 2 by anything to get 7. I could probably plug, there probably is something, but we don't want to deal with any decimals. Let's stick to whole numbers as much as we can. So we can't really get rid of x. So let's go ahead and move over to y. And this one is a little bit easier because if I double 3, that will be 6. So I can make them the same number by just changing one equation. So I think that's what I'm going to do. I'm going to change, well, I'm not going to change this top one. I'm going to leave that one the same. And it's always best to change as few things as possible, because the more things you change, the more chance that something's going to come up that's going to be confusing. So like I said, I need to double it, but it's not just enough. It's not enough to just double it. We're also going to have to multiply it by negative 2, sort of like what we did with this one. So we're going to have to change the sign on everything. So this would be negative 4x, and negative times negative will be positive. 3 times 2 is 6y, and again, we want these to be opposite, so negative 6, positive 6. Negative, for our last number, negative times negative is positive, and 13 times 2 is 26. So there we go. And now I'm going to go ahead and put these two against each other. So 7 minus 4 is going to be 3x equals, and then 53 minus 26. And I don't grab my calculator for this one here. So 26 minus 53, and that would be 27. Okay. Oh, and the negative is bigger on this here, so I got to double check that. So double check my work, because I just noticed that this negative is bigger. Now, wait, what number was it again? Oh, wait. Oh, okay, negative 27. There you go. Check my calculator. Almost put the wrong number there. Divide both sides by 3. And then let's see, x equals 27 divided by 3, which I think is 9. Don't forget the negative, so it'd be negative 9 is our first part of the solution. All right, but again, that's not the full answer. We need both pieces. So let's go ahead and take negative 9 and plug it back into one of the originals now. Which one works best? And I'm just going to use the bottom again. Again, both of them will work. They're both describing the same thing, so it's not like one is not going to give you the right answer. Okay, so x is equal to negative 9, so 2x, so 2 times negative 9 plus minus 3y equals negative 13. 2 times negative 9 is negative 18. And then let's see, it looks like I'm gonna have to add 18 to both sides because I want to get rid of this 18. And again, right now I'm just using my normal algebra stuff. You know, isolate your variable, take care of any groups, move all your variables to one side, do the adding and subtracting, or wait, and then the multiplication division. And this one seems like a bit of an odd one because I'm going to get a fraction for this one here. And I don't see anything I did wrong. I've been paying attention to all my steps up to this point, and I'm guessing that some of these will be fractions. Now, I'm going to have to check the homework on this one and get back to you, because I know on the other one, they did not give you any fraction answers. So I'll check the homework and let you know if any of these are, oops, not a big deal, but I put the variable, it should have been y. Got too busy thinking about fractions, so like I said, I'll look at the homework and get back to you to see if you can expect fractions, because I know the last one didn't, and I think it's just a little easier if you don't have to deal with so many fractions. Anyway, let's go ahead and move on from here. All right, and let's see, solve each systems of equations below by elimination and then identify the solution. Okay, so look at our variables. So again, they're all, the equations are in the same order. So x, y equals number, x, y equals number. So they line up. Now, let's look at this here. So 3, if I double that, I get 6, not 7. And the soonest number they would meet up at would be 21. So, yeah, I'd have to change both of them. And that might not be so bad, but let's see if we have a better option with the x's. So 5x and 2x, the number they will meet up at, oftentimes what is called the least common multiple. All right, but I don't need to be introducing additional vocabulary. So again, if you were to multiply by 5, and maybe, okay, let me explain this a little bit more. So it's like multiples of 5, 5, 10, 15, 20, 25. And then multiples of 2, 2, 4, 6, 8, 10. And multiples of 5, you notice that I said 10 also. So 5, 10, 15, and so on. So in this case here, 10 is the number they will meet up at sooner, the soonest number they will meet up at. So this means I'm going to have to double everything on this one. So I'm going to go ahead and double that. 10x plus 6y equals negative 14. All right, and then I'm going to have to do the same thing for this bottom one. So for this bottom one, I need this to be 10 for the x. So that means I'm going to need to multiply it by 5. Now I'm also going to need a negative number too, because if they're both 10, they're not going to eliminate. It's just going to become like 10x plus 10x would be 20x. But again, we don't want bigger numbers. We want them to eliminate. So I'm going to have to multiply it by a negative. So that'd be negative 10x. And then 7 times negative 5 would be negative 35y equals, and then 5 times, or 3 times negative 5 would be negative 15. Okay, double check our numbers, make sure they're each multiplied by 5 and that their sign is different. So plus, 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 negative, negative, negative. So they've all undergone a sign change. So in the top one, we didn't change anything except we just doubled everything. So all the signs should be the same. Now I'm going to go ahead and combine them. So as they say add or subtract the equations. So 10 minus 10 is going to be 0. So that will be the one to eliminate. 6 minus 35 is going to be negative 29. Y equals, and then negative 14 and negative 15, put those together, you get negative 29. And in this case, it looks like we're going to get a nice number for this here. So I'm going to minus 29, I'm sorry, divide both sides by negative 29. Because again, what number times negative 29 gives us negative 29? Well, that's easy. Should be y equals 1. And that's our first solution. And it's a whole number, so I'm pretty sure this is the right one. If you have a fraction, you should definitely check it again to make sure you didn't do anything wrong, because I think even though they are around, they're not going to happen all the time. So anyway, we got one of them. Let's go ahead and plug this into one of these here and get it solved for the other one. So I'm going to just use the top one just because the last one we used the bottom one. 5x plus 3y, but in this case y is 1. 3 times 1 is, well, 3. 5x plus 3 equals negative 7. And I'm going to have to get this 3 out of here, so minus 3 from both sides. 5x equals negative 10. And if I ask you what number times 5 could give me negative 10, well, okay, so 5 times 2 would be 10. But I also need negative 10, and the only way to get that would be if one of them was a negative. So we might have what we need here. So x is equal to negative 2. Now that we have both of them, I'm going to go ahead and write it as an ordered pair. So negative 2 and y is 1. So put that in ordered pair form. And it looks like we are done with that one. Okay. Let's go ahead and move on to the next one. So in this case, y is not a good candidate because they don't match up. And if I were multiplying by 9, so 9, 18, 27, 35, 36, 45, and so on, I think the soonest number that those would meet up at would be 36. So I guess I could do that. But let's look at x as well. So x, this one would be a much smaller number. It would be 12 because 4 and 3, if I were going with multiples of 3, that'd be 3, 6, 9, 12, 15. 4 would be 4, 8, 12, 16. So 12 is where these numbers will meet up at. All right, and let's go ahead and start setting this up. So 3x minus 9y equals 9. Now I'm going to have to, darn it. I just said I was going to have to multiply both of them by something. Okay. So I'm going to have to multiply this one by 3, which I'll probably make it negative 3. And the top one, I'll multiply it by 4. Okay, so let's go ahead and do this. So 3 times 4 is 12x. 4 times negative 9 would be negative 36. Y equals 4 times 9. 4 times 9 would be 36. And then looking at the bottom one, so I got to multiply everything by 3. So this would be 12x, but again, it's going to be negative 3. So don't forget the negative. Negative times negative is positive. 12 times 3 is 36. And 36 times negative 3 would be 108. So negative 108. And let's go ahead and combine our equations together. So 12 minus 12. All right, that would be 0x. And then 36 minus 36. That would be 0y. So what happens here? Okay, so we do kind of run into a bit of a problem because, well, we don't have anything. Now, remember, there is a way to think about what's going on, right? So right now, let's go ahead and verify it. So remember, when your variables drop out, there's a test that you can do, and that is to check to see if it makes a true equation or a false statement. But here, I'm going to go ahead and just remind you that we have, show you that basically what's going on. So just a reminder that these are lines, right? So these are lines that happen, and you can check any of these problems using Desmos. So I'm going to go ahead and plug those equations in, and let's see what we have. All right, so there is no intersection. They do not cross each other at all. So that's why, well, I almost said it there, but what does that mean? Well, it means that there is no solution. So if your variables, okay, so there's three ways to kind of test this out. If you lose both variables, so remember that's what it means in like when you're solving something in basic algebra. If you lose your variable, that means that you don't, well, okay, so if you lose your variable, there are two things that can happen, and that is there could be no solution or there could be infinite solutions. And in this case here, it's no solution because it's a false statement. It's untrue, right? Because 0 times x would be 0, 0 times y would still be 0. So I'd get 0 equals, and let's see what's on this side, 36 minus 108. That'd be negative 72, right? That's false. 0 is not the same thing as negative 72. If you got something like 0 equals 0, this would be an infinite solution. Or if at any time you can make both of these equations into the same line, then that's another way you can kind of tell, because if it's the same line, if both equations match perfectly, then that would mean it's an infinite solution. Okay, but just a quick refresher. And you can always just graph it too, like I did. And the same works with all of these too. All right, so if I graph this one, it should meet up right there. Okay, now for this one here, I think we got a few more, 1, 2, okay. I'm not really sure what I included in the packet. I think I removed some pages just because I didn't want the packets to be too large. Actually, you know what, I might check something really quick. Okay, so I'm gonna go ahead and just show you what I'm working on. So don't forget that you have Schoology, right? So with Schoology, you can check what you're working on. In this case, it looks like I only have up to week 6, but you can check the packets here and look at what we have. And it looks like, okay, linear equation. So I think I'm a little bit. All right. Okay, that's not going to work. But anyway, just a reminder, you can look on Schoology and get the packets from here. So if you live out of town or whatever, you can check here and you can get the packets. You could probably also screenshot what we're working on. You could probably, you know, if you have a phone or whatever, you can take a picture. That way, when your packet does show up in the mail or however you get it, you can still work on it, right? You know what's going to happen. So, okay. Anyway, looking at this here, they're not in order. So if we look at the order 5, or sorry, x, y equals number. Here, y equals x number. So this is not going to work out. All right, so since it's not going to work out, we're going to have to change this, because remember, that's the first step, is to line them up, line up the equations. So what I'm going to have to do for this is I'm going to have to, I'm going to minus 2x from both sides. And this should give me negative 2x plus 7y, because this is a positive 7y, equals 8. Now they should be in the same order. X, y equals number, x, y equals number. So it does match up. All right, and I'm just going to cross this out. It's probably not a good idea to cross it out on your packet because you might need it later. But for now, it just allows me to focus on these two here. Right, I got this one and this one here. Now that they're in the same order, let's try to get one of them to match coefficients. So 6 and 7, well, multiplying by 6 and then multiplying by 7 is not really going to work out that well for us because the earliest number they can meet up at is 42, and I want to keep these numbers small. And again, let's try to work on the minimum amount of things. Let's change the smallest amount of things as possible. So I'm going to have to double this one, so times this top one by 2. And I'm going to have to times this one here by 5. And they're already opposite. So negative x, and that one's positive x. So I don't need to change the signs, which would make at least a little bit, make it a little bit easier. So let's go ahead and multiply the top one by 2. So that'd be 10x minus 12. Oops. 12y equals, and then 3 times 2 is 6. So let's double check it, make sure we doubled everything, check our signs, looks fine. Here, let's see, I have negative 10x. 7 times 5 is 35. And 5 times 8 is 40. Okay, now I think we're ready to put these together. So 10 minus 10 is going to eliminate. 35 minus 12, I'm thinking it's 23. Okay, I would have guessed wrong. So 23y equals 46. All right, and this one looks like a pretty easy one. What number can I multiply by 23 to get 46? Okay, well, if I double it, that'd be y equals 2. So 2 times 23 is 46. And now we got our first part. We got the first part of the solution. Let's plug it back in and get the other one. And again, I don't know which one is better, but I'm going to probably use the top one. And I could even use this original one here, but I don't think that's going to work very well because in this case here, x is going to be in the middle. So I'd rather pick something where it's easy to solve for x. So that's why I'm still not going to use this one here. 5x, let's see, 5x minus 6y, but we know y is 2 because we just got that. And then 5x minus 12. And I'm going to have to add 12 to both sides. So 5x equals, adding 12 to both sides, 3 plus 12 would be 15. And that would allow me to get my x value. So x is equal to 3. So now I have both parts of the equation, both parts of the solution. So the only thing left for me to do now is to write it as an ordered pair. So 3 goes first because it's an x. And then 2 is the second one. And it looks like we are done with this one. Not bad. All right, so same thing with this one. Let's check to see if it's in order, which this one looks like it's a pretty big mess because, well, hold on, wait a minute. No, actually looking at it closer, it's not that bad because x number equals y. The only thing we would need to change for this bottom one would be to switch the placement of the x and the number. And again, they don't have to be in standard form. They don't have to be in the same, any form really. They just have to line up. So to change this one here, all I'm going to do is just switch the order so that 9x goes first, then plus 4, right? Because we're adding, that's a positive 4. And there you go. All I did was just switch where 9 and 4 were, and that's it. Now they line up. So y equals number plus x. So again, they just have to line up. It doesn't have to be in any specific order or anything like that. They just have to line up. And I didn't have to do a whole lot for this one here. So now let's go ahead and focus on eliminating one of these numbers. So what can I eliminate now? Both of them seem kind of equally easy. I don't see one being any easier than the other, because here, if I wanted to eliminate y, they would meet up at 40, and over here they'd meet up at 90. So actually, I think it'd be a little bit easier to do y, because one is already negative. I already have one of them that's a negative. So I'm going to go with y. So I'm going to take this top one and multiply it by 5. So I don't need to multiply by any negative numbers. Take this bottom one here and multiply this one by 8. All right, so multiply the top one by 5. That would be 50x plus 5 times 18. 5 times 18 would be 90 equals, and then 8 times 5 is 40, but don't forget that it's negative. There we go. Now let's go and do the bottom one here. So this one here, remember we had to reorder it. So we get 72x plus, and then 8 times 4 is 32, but let me double check that. 4 times 8. And that is indeed going to be 32. Now I'm going to have to multiply the last one. So this would be 40y. And I think it would have been better to put them in like both standard form or something. But I'm also going to show you again, that's not really necessary. That's one good thing about this one here. Now I'm going to go ahead and add these two together. So 0 plus 2 and 5 plus 7 is 12, so 122. And then here I would have plus 12, 122 equals, and if you have something on the same side that eliminates, it would be 0. All right, so I'd get sometimes students that would say something like, isn't that no solution? No, it's 0, okay? So if you have nothing there, it's no solution. So we did manage to eliminate the y. There is no more y. But we got everything on one side, so that means I'm going to have to move all the stuff away from the x. So I'm going to minus 122 on both sides. And divide both sides by 122, which would actually be pretty easy because they already match. X equals -1. And again, there's their first part of the solution. Now we're going to have to pick one of these, and I could pick the original as well. And I don't know if the original would be really that good or not, but you know, I'm going to just pick the top one. I don't know if that's the best way to do it, but it is definitely a way to do it. So, and again, there's no wrong ways. You can pick the bottom or the top. Okay, and then now we need to find out. And I want the top one as well because it's already solved for y. See, y is already on pretty much the side itself by itself already. So that's just going to make it a little bit easier to work out. Okay, so 10 times -1 is -10. And here 8 minus 10 would be 8. And now I have to divide both sides by -8. And let's see, that's going to cancel the negative, cancel the 8. Y equals -1, because 8 divided by -8 would be -1. Okay, well, I guess that works out. because our ordered pair would just be -1, -1. Okay. All right, so like I said, I might have to break this one into 2 lessons with some of these word problems. I might just do the page, this page here. So in the packet, there's 3 of them on this page here, and this is the next part here. So there's only like 3 of them, and then we'll finish this page, and then we'll save the rest for tomorrow. For the packet, the word problems for tomorrow, I think it's like 8 problems. So I guess we'll just have to split that one up. All right, so solving applications using elimination. So first thing is define your variable. So what are we solving for? What are we trying to get? And then, and this helps if you write it down as well. So next thing you'd have to do is set up 2 equations using the information they give you. And then it says solve using the method of your choice. So this means that we can use substitution if we want. So remember, again, there is kind of a measure of points for following the directions. So this one does say that we can use either one we want. So if something, for instance, works better with substitution, we can use it. But anyway, let's go ahead and go through what we have. So number 9, Marcy bought a total of 20 used books and CDs during a yard sale for a total of $54.50. If the books are $1.50 each and CDs are $5 each, how many of each did she buy? All right, so let's look at the first one. Now, again, sort of like a, let me just, I don't know if I can do this really quick, but they have a couple of different things. There's usually an introduction when it comes to word problems, and then you have your clues and then your question. So introduction, all right, so we know that there's a yard sale, and this person bought several items from this yard sale. Clue statement, so these are usually the ones with the numbers in them. The clues are books are $1.50 and CDs are $5, and that she bought 20 of these in whatever combination. So the question is, how much of each did she buy? So we actually have to answer 2 questions for this. All right, so let's go ahead and start putting them in together. So we could have, I'm thinking we could just use X and Y, or maybe we could use B and C. We'll make B equals books and C equal CDs. All right. Now remember, there's the first sentence here says there's 20 of them. So she bought 20 of these. And we don't know what combination it was. You know, we could have 10 books and 10 CDs. We might have 15 books and 5 CDs. Or something, okay? But the first thing is the number is 20 of them. Whatever combination, there has to be 20 of them. It could be 13 books and 7 CDs, right? And any of those combinations. And then the second one are the value. So here we have $54.50. And for the second one, it's going to be the value of each one. So books are $1.50, so 1.5 for B, and then CDs are $5 a piece, and whatever this combination is, and again, it could be anything. It could be 10, and if it was 10, this would be $50 of CDs and $15 worth of books. So that would be something way higher. It'd be like $65 or so, which is not the right one. So that's why we have to use the system of equations to solve it. And this comes out to $54.50. And I'm going to leave the zeros out just to make it a little bit easier to work with. Now we have to pick one of these to eliminate. So what number could we eliminate? Now I could multiply the entire top thing by 1.5 so that B would cancel. But that actually seems like a lot of work. I don't want to multiply by decimals if I have to. So I'm going to try to get this to be a 5. So I'm going to multiply everything by -5. So -5b, and this is a lot easier because all I have to do is just 1. These are 1, so 1 times -5 would just be -5, and this would be -100 because 20 times -5 is -100. Now I should have enough to get one of these to cancel. And let's see, I got my calculator here. So 1.5 minus 5, and that would be -3.5b. And this is going to cancel out, right? Because 5 minus 5 is it's going to be 0. And over here, 54.5 minus 100, it's going to be 45.5. Oh, negative, because -100 is obviously bigger. And now I'm going to divide both sides by -3.5. Divide by 3.5, and I'm going to get 13. And that makes sense because, you can't buy a fraction of a book. So if you remember maybe like 2 weeks ago when we were talking about word problems, I was mentioning something about what I call the sniff test. And the sniff test is basically, does this make sense? Okay, so can you go into a store and buy half a book? What store would let you do that? None. Okay, there's probably not a single bookstore anywhere that would let you buy half a book. Unless, of course, it was probably sold by EA Games. EO. Anyway. So we got one of them. We know that there's 13 books. So if there's 13 books, how many CDs do you think were bought? And this one should be an easy one because, well, we already know that it has to add up to 20, right? So that would mean the Y would have to be 7 because that's the only way you can add it up to 20. And this one's a little bit easier than doing the other one because, plugging, even if I plug it in, that would be super easy still. So we know that, in this case, B is 13. 13 plus C equals 20. So the CDs, there were 7 of them. All right, and I didn't have to do the math because I already knew it added up to 20. And I don't know if this one would be a good one to, and I also noticed that I changed it from X to Y. So B and C should have been B and C, not X and Y. Just out of habit. And in this case, it doesn't make sense to put them in X and Y or ordered pair because, well, nobody anywhere ever said books have to go first before CDs. So we could just say 13 books and 7 CDs. And that's probably a much better way of saying it rather than as an ordered pair because it doesn't really make sense, again, to say which one goes first or anything like that. And we only said books here because it was mentioned first. So it mentions books, then CDs. So we just put books first. But again, we don't really need to do that. Okay, so like I said, let's do these other 2 and then we'll call it a day. All right, Landon babysits and works part-time at the water park over the summer. 1 week he babysat for 3 hours and worked at the water park for 10 hours and made $109. So that's week 1. So again, introduction, we know this guy has 2 jobs. And first clue statement, 1 week he babysat for 3 hours and worked at the water park for 10 hours. The next week, he babysat for 8 hours and worked at the water park for 12 hours. So that's our second clue statement. And then the question statement, how much does he make at each job? So again, we have two clues. So this one should be an easy one to break down. So first clue statement is the first week. So babysat. So we'll put B as babysat. And we'll use W for water park. I don't know if that's a, oh well, it works. So it says here he babysat for 3 hours. So 3 hours babysitting, so 3 times B, plus water park. So he worked 10 hours at the water park, so 10W, and he made $109. The next week, so the next week, and this one makes it pretty easy because the next equation, he babysat for 8 hours and got 12 hours at the water park. And, oh, sorry, just force a habit right there. 12. 12 water park equals 177. All right, there we go. So now, how much does he make at each job? Okay, so it looks like we're gonna have to get one of these to eliminate. And I could make both W's equal 60, right? Because I could times this by 6 and times this one by 5, and I would be able to get both W's to be 60, but I think the B's would be a little bit easier. I'd have to make them both 24B. And I'd also have to make one of them negative as well. So I'm gonna make this top one negative. So I'm gonna times everything by -8. And for this one here, I'm gonna times everything by 3. Okay, so times the top one by -8. So 10 times -8 would be -80. W equals 109 times 8. 872. Oh, -872. Don't forget your signs. Okay, now the bottom one, let's multiply everything by 3. So 8 times 3 is 24. That works out. 3 times 12. Let's see, 3 times 12 is 36. And then 3 times 177. That'd be 531. And don't be afraid of large numbers because just sometimes it just works that way. And then 36 minus 80. That'd be -44. So -44W. And let's see, 531 minus 872, that'd be 341 negative. And it doesn't make sense for someone to make negative money. So like, let's say I forgot that negative. Okay, and nobody goes to a job and makes negative money. So, okay, now just doing the math, I get $7.75 here. So if I again, this makes sense. Negative divided by negative is positive, but let's, again, give it the sniff test. If I said it was -$7, nobody would work that job. Nobody wants to pay money to work somewhere, unless it's Mr. Krabs. So that's what I mean by sometimes you just got to give it a sniff test. And $7 seems very reasonable. Well, I'm guessing this book was written, it says here the book was written in 2015. I don't remember what minimum wage was in 2015. I know Arizona's always been kind of high. But I think it was $10 even back then. I don't know, maybe this is another state because we don't have very many water parks here, only like 2 that I can think of. And they're both in Phoenix. Anyway, so there you go. Now that we know this person makes $7.75 at the water park, let's go ahead and take one of these and plug it in to get the other one. Okay, so we want to find out how much he makes babysitting. So let's go ahead and use this top one, and I'm only using the top one because it has smaller numbers and it has multiple of 10. So multiplying something by 10 in this case is going to be super easy. So we know he worked 10 hours at the water park. At $7.75, that would mean he'd make $77.50 that day, that week, that first week. Now I'm going to take 109 and minus 775, and that would be 3b equals 3150. Divide both of them by 3, so divide that by 3, we get $10.50. So babysitting equals $10.50. Now let's go ahead and write our answers out. So $10.50 babysitting, and $7.75 at the water park. So the water park probably doesn't, well, I don't know what he would be doing at the water park. I feel like lifeguards should be paid more, but then lifeguards have a pretty easy job unless somebody, well, no, it's not easy. Because if things go wrong at a water park, you better hope your guy's not getting paid minimum wage. Yeah, I think lifeguards would probably have to have lots of certification, CPR, first aid, all that stuff. So all that's going to drive up the price. So even though they sit around a lot, I'm sure they make a lot of money. He probably does something else like, I don't know, janitor, works the pumps, or runs a snack bar. Who knows? Anyway, last one. So we've seen one like this one before, where there's pennies and nickels. So let's go ahead and put that down. P equals pennies, and N equals nickels. And here we have a collection of pennies and nickels that are $1.98. So it doesn't matter what they're worth, just the number of pennies and the number of nickels. Wait a minute, hold on. In this case here, no, we are talking about what they are worth. Okay, hold on a minute. We should read the whole question before moving on, because this question is a little bit different than I thought. All right, so pennies and nickels that have a value of $1.98. The number of pennies he has is 5 less than twice the number of nickels. How many of each coin does Kent have? So again, this one's a little bit different than I thought, because we did run into a problem earlier, I think last week, that was very similar to this one. So what do we have? A penny is 0.1, and a nickel is 0.05 nickel equals 198. All right, so that was the first part. And the second part is going to be a little bit tougher because that was our first clue statement. So remember, introduction, Kent has a collection of pennies and nickels. And actually in this case here, pennies and nickels with a value of 198 is also one of the clue statements. The number of pennies he has is 5 less than twice the number of nickels. So number of pennies, okay, so let's see. Pennies, so pennies is means equal, so pennies is 5 less. And this one's a tricky one because whatever number we're looking at, we're gonna have to lessen it by 5. 5 less than twice the number of nickels. So to put it in a little bit more of an easier to read, it'd be 2n minus 5. So again, twice the number of nickels, and then lessen it by 5. So remember when we were talking about word problems, and I gave you that big old list of word problems, the clue words, I said that less than is the tricky one because less than is the only one that is opposite of what you might think it is. It's not an inequality, it means subtracting, and that second number is, the number that says less than is the number you're subtracting with. Ooh, okay. But again, it's a little bit backwards than you might think. Anyway, this looks right to me. So let's go ahead and keep going with this. I'm gonna have to plug it in. Now here, it's already solved for P. So this is it's gonna be, for me, I'm gonna say, let's use substitution. So I'm gonna plug the whole thing into here, and I wanna kind of go a little bit faster. I notice time is a little bit, just we gotta be cognizant of the time. 0.02n minus 5, which is 0.05 plus 0.05 n equals 198. Hope I don't make a mistake on this. Okay, and then combine our like terms. So I have this one and this one, so that'd be 0.7 n. And I'm going to add 0.5 to both sides. Add 0.05 plus 0, because I'm trying to remember, I'm trying to move all my regular numbers to the other side. And this would be $2.03. Okay, now I'm going to have to divide both sides by 0.07. And a calculator might make this a little bit easier, although if you were using regular division, all you'd have to do is multiply both numbers by 100, move out the decimal, because remember, you can't really divide by a decimal number. 2.03 divided by 0.7, and that would be 29. And that makes sense. 29 nickels is, it's not unreasonable to have 29 nickels, but you can't have half a nickel. You can't have like 0.3 of a nickel. So if you made a mistake, then it would probably be a weird number. But in this case, it makes sense. Okay, now it does not tell us the number of nickels he had, or maybe it does. Oh, we could plug it into this one right here. So look, this one's already solved for P. So once I plug in here, so we know he has 29 nickels, because we know that the number of pennies is 5 less than twice the number of nickels. So if we hypothetically double the number of nickels, that would be, let's see, 2 times 29 is 58. Yep, 58 minus 5, and that would be 53. So pennies are 53, and we could check it. So, you know, we haven't really checked a whole lot of these, so we'll check this one really quick. So 53 pennies and 29 nickels. And really quickly, let's just plug it in to see if it makes sense. So P, so pennies are 53, so he has 53 cents in pennies plus 29 nickels, so 0.5 times 29 would be $1.45. And does that equal to $1.98? Plus 0.53, and yes, it does. So 1.98 equals 1.98. So we know this is the actual solution, and you can pretty much do that with all of them, and I haven't been checking them, okay? But if you ever want to check them, that's how you would do it. Just plug it back in and see if it works out. And don't forget to give it the sniff test, because, all right, math usually has to do with real world stuff. And in this case here, again, it's not possible to have half a nickel. And if you did have half a nickel, would it be worth 0, or would it still be worth a full nickel? Well, I don't know, but either way, half a nickel is just not something that people generally deal with all that much. Anyway, I guess that's it. We have reached the end of this one. So if you have any other questions, I'll be around for a bit, but if not, I will see you later. All right, so bye-bye.